An artist knows that if she mixes red, green, and blue paints, the result will not be white, but a muddy dark brown or black color. Red and green paint certainly do not combine to form yellow, as red and green lights do. Do you wonder how this could happen? These colors are actually produced by mixing pigments. At the end of this lesson, you should be able to compare and contrast the mixing of pigments with the addition of colored lights. We have seen that mixing pigments can produce different colors. By mixing all three primary colors in specific proportions, almost all colors can be produced. From the diagram of the primary colors for pigments, we can see that mixing red pigment with yellow pigment produces the orange color. Mixing red pigment with blue pigment produces the violet color. Mixing blue pigment with yellow pigment produces the green color. Mixing red, blue, and yellow pigments will produce the black color, which is different from mixing red, blue, and green colored lights. Mixing pigments produces different colors compared to mixing colored lights. The picture shows a comparison of mixing colored light and mixing pigments. The addition of primary colors for colored light. The addition of primary colors for pigments. The color of a mixture of pigments is obtained by the subtraction of colors. The process in which an object shows its colors by absorbing certain colors of light but reflecting others. What color do you expect will appear if red pigments are mixed with green pigments, or when orange pigments are mixed with violet pigments? When red pigments are mixed with green pigments, brown color is obtained. When orange pigments are mixed with violet pigments, red color is obtained. Table 1 above shows the colors obtained when different pigments are mixed. As you have learned, mixing colored pigments can be used to form all colors except white. Mixing pigments of all primary colors will produce black. However, mixing all primary colored lights will produce white. Drag and drop the correct color into the empty boxes and click Check button to check the answer.
Your answer is correct. That's not right. Please try again. Your answer is incorrect. This is the correct answer.
Click on the correct answer. Which of the following statements is not true about mixing pigments? A. Mixing pigments can produce black color. B. Mixing pigments can produce white color. C. Mixing pigments can produce secondary and tertiary colors. D. Mixing pigments can produce colors based on the principle of color subtraction.
Your answer is correct.
An artist mixes the same amount of blue paint and yellow paint. The color obtained is A. Red, B. Green, C. Magenta, D. Orange.
Your answer is correct.
Figure shows the effects of mixing three colored pigments. What is the color obtained at P and Q? A. Magenta, white, B. Violet, white, C. Magenta, black, D. Violet, black.
Your answer is correct.
Which of the following are the primary colors for pigments? A. Red, blue and yellow, B. Red, blue and green, C. Green, indigo and orange, D. Cyan, magenta and yellow.
Your answer is correct.
Which of the following is the similarity between mixing pigments and addition of colored lights? A. The product of mixing pigments is the same as the product of mixing colored lights. B. Both the addition of colored lights and the mixing of pigments produce primary colors. C. Both the addition of colored lights and the mixing of pigments produce secondary colors. D. Mixing pigments and the addition of colored lights are based on the principle of light subtraction.
Your answer is correct.
In this lesson, we have learnt that the primary colors for pigments are red, blue and yellow. The secondary colors for pigments are orange, green and violet. Mixing of pigments form colors that are different from the addition of colored lights. Observe these photographs. What makes the photographs different from each other? One of the photographs is colored photograph and the other is not. Click Info button to learn more about color photography. Color photography started at the late 19th century. Initially, the color could not fix and fade easily. Modern-day color photography overcomes these problems by using silver chloride and silver halide. By using combination primary colors on different sensitive layers, a colored image can be produced. Combination of colors are done by subtraction of colors.